Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about graphing quadratic functions. All right, well, what is a quadratic function? Now, the standard form of a quadratic is in the form y is equal to ax squared plus bx plus c, where a is not 0. Now, a cannot be 0 because if a is 0, I no longer have a quadratic function. I have a linear equation. Okay, so a needs to be something other than 0. B can be 0 and C can be 0, but A has to be something other than 0. The graph of a quadratic function is a parabola. And you can see that in this case I've drawn little two eyes, so I've got a happy face parabola. The parabola is opening up. So standard form of a quadratic function, ax squared plus bx plus c, where a is something other than 0. And the graph of a quadratic function is a parabola. So parabola is in a U shape. Now you have to remember also that the a, b, and c values are listed in front of x squared, x, and then c is the constant. So it's important to know that a, b, and c are relatively placed, and they're important as we go through definitions about the features and characteristics of quadratic functions and parabolas. All right, so graphing quadratic. The parent function of a quadratic function is y is equal to x squared. And y is equal to x squared is drawn below. The vertex is the lowest or the highest point of the parabola. So in this case, here's my vertex. It's the lowest point of the parabola. In the parent function, y is equal to x squared, the vertex is 0, 0. That makes sense because if I plug in 0 for x, 0 squared is going to be y. So the parent function, the vertex is 0, 0. And regardless of what I put in for x, I'll always get a positive number out for y. So that means that the lowest that y is going to be 0. Now the axis of symmetry is the line that divides the parabola into two equal halves. So something that is symmetrical has two halves that are exactly the same. So the axis of symmetry divides the parabola into two halves, and it's that red dotted line that goes right through the center of the parabola. And it just so happens that the axis of symmetry passes right through the vertex. Okay, in the parent function, the axis of symmetry is x is equal to 0. So it's a little counterintuitive, but the line x is equal to something is a vertical line. And the axis of symmetry for all parabolas is going to be x is equal to something. So I have x is equal to 0 in this case. The vertex is 0, 0. And sometimes in the future, I will identify the axis of symmetry in short as AOS for axis of symmetry. Okay, next slide, a lot of information. All right, so we take the characteristics of a quadratic graph. In the standard form, y is equal to ax squared plus bx plus c. A cannot be anything other than 0, or it has to be something other than 0, excuse me. Now, if the sign in front of a is positive, the parabola is going to open up. So if a is positive, the parabola opens up. If the sign is negative, it's going to open down. So if the sign in front of a is positive, it opens down. And this is very similar to the absolute value functions. If the absolute value of a is greater than 1, then the graph is going to be narrower. So if a is greater than 1, then the graph becomes closer to the axis of symmetry. If the absolute value of a is less than 1, the graph is wider, so it moves further away from, the sides move further away from the axis of symmetry. Right, now very important, I can figure out the axis of symmetry because that equation is x is equal to negative b over 2a. So x is equal to negative b over 2a. I can take the first example and figure out what the axis of symmetry is. It's going to be, if I take my first example, so here's my first example, y is equal to x squared plus 6x. My first example, I have minus b, which is minus 6 over 2a, or just 2 times 1. So my axis of symmetry is going to be x is equal to negative 3. So it's not negative 3, it's x is equal to negative 3. That's the equation for a line. Negative 3 is just a value. You have to create an equation between x and y to form a line for the axis of symmetry. In this case, it's always going to be x is equal to something. In my second example, I can figure out the axis of symmetry. So I take my second example. I have minus b, which is 4. So minus a minus 4 is 4, over 2a. It's going to be 2 times negative 1, negative 2. So my axis of symmetry is going to be x is equal to negative 2. Okay, so we can figure out the axis of symmetry. And why is that important? It's important because the axis of symmetry goes right through the vertex. So if I have the x component for the vertex, then I can figure out the y component by just plugging it right back in. So in the first example, I know that the vertex has an x-coordinate of negative 3. I can figure out what the value of the y-coordinate is by plugging in the value of x and solving for y. So here I have x is equal to negative 3, so negative 3 squared plus 6 times negative 3, right? And I'm just getting, I'm plugging in the negative 3 that I got for the axis of symmetry. I'm plugging that into this equation, and I end up with y is equal to 9 plus negative 18 plus 9, which ends up being 0. So my vertex now, I figured out my vertex is going to be negative 3, 0. So here I've graphed it out, vertex is negative 3, 0. And the y-intercept is simply 0c. And the c value in this case is just 9. So my y-intercept is 0, 9. All right, let's talk about minimum and maximum values. If the parabola opens up, then I have a minimum value. It's a value that no other point is going to be lower than. So here's my minimum value. And when we refer to a minimum value, we're talking about the x value. So the y value. The y value is going to be the minimum value. So in this case, the y value is 0. 0 is my minimum value. In this case, I have a maximum value. If the graph opens down, then my maximum value is going to be, in this case, I'm not sure if 16 is exactly the right number, but it's going to be some value of y. So my maximum value I get when I have a graph that opens down, so my a value is negative. And a minimum value I get when my a value is positive because the graph opens up. Now again, the minimum and maximum values relate to the y component. So whatever the y value is for the vertex, that's going to be your minimum or maximum value.